Hello dear students, welcome to the course of Engineering Thermodynamics. Myself Mihir Misri, Assistant Professor from Mechanical Department of LJ Institute of Engineering and Technology. So today we are going to continue our session on vapor power cycles, and in particular we are going to discuss about reheat regenerative cycle. So let us start. So for understanding the reheat regenerative cycle, as you can see on the screen, the diagram, typical diagram of the components of reheat regenerative cycle is shown over here. Now before understanding this lecture, I will advise you students to first watch the video of reheat cycle, then regenerative cycle, because reheat regenerative cycle is nothing but combination of reheat and regenerative cycle together. So it will be much more easier to understand. Okay, so now first of all let us understand the diagram clearly, conceptually. So as you can see, we will start from the boiler that is on the left hand section of the screen. So from boiler outlet, the steam will be supplied to the turbine. So as you can see, 1 kg of steam is supplied to the turbine at point number 1. Now we have here two turbines, that is high pressure turbine and low pressure turbine. So now at point number 1, that is the inlet of the high pressure turbine, steam will be entered. Okay, obviously this will be superheated steam. Okay, so now what will happen at the intermediate stage of the turbine, some amount of steam will be extracted, that is highlighted by point number 2 at below the high pressure turbine. Okay, so you can see that from point number 2 you are extracting m1 kg of steam. Now this m1 kg of steam is supplied to heater 1. Okay students, heater 1. Now we will keep up to this point. Now what happened further? If from high pressure turbine, if you are extracting m1 kg of steam, the supply was 1 kg. You are intermediately extracting m1 kg. So now what you are left with? 1 minus m1 kg. Simple and easy to understand. So this remaining 1 minus m1 kg of steam will be rejecting out from the turbine outlet, that is point number 3 shown in the diagram. Now from point number 3, this steam will be again sent back to the boiler for reheating. Okay, so now reheating will be done. Okay, so remember students, for reheating we are using or we are sending 1 minus m1 kg of steam. Clear? So now this 1 minus m1 kg of steam is supplied to the boiler again for the reheating. If you are reheating that, then what will happen further? This reheated steam is supplied to the low pressure turbine. Okay, low pressure turbine. So now at point number 4, you are having the reheated steam at the inlet of the low pressure turbine, as you can see on the diagram. Okay, now further what will happen? In the low pressure turbine also, at the intermediate stage, we are extracting, let us say, m2 kg of steam, that is shown by point number 5, and this m2 kg of steam is supplied to heater 2, as you can see in the diagram easily. Right, I am repeating again, in the low pressure turbine, at the inlet of the low pressure turbine, you are supplying the reheated steam at point number 4, and at the outlet or at the intermediate stage of the low pressure turbine, that is point number 5, you are extracting m2 kg of steam. Okay, now remember at point number 4, that is inlet of the low pressure turbine, you are supplying 1 minus m1 kg. And at point number 5, you are again extracting from that 1 minus m1 kg, you are extracting m2 kg, and you are supplying that m2 kg to heater number 2. Clear? Now, what remaining portion of the steam will be there in low pressure turbine? See, at the inlet of the low pressure turbine, you have 1 minus m1, and from 1 minus m1, you are extracting m2 kg. So now, what you are left with? So 1 minus m1 minus m2. That much amount of steam will be left, right? Okay, but further from this 1 minus m1 minus m2 kg of steam, again at the later intermediate stage, that is shown by point number 6, you are again extracting some amount of steam, that is shown by point number 6. Okay, so you are extracting m3 kg of steam at point number 6 as shown in the screen. Okay, so this m3 kg of steam is extracted and supplied to heater number 3. Okay, now what we are left with, again I am telling you, we were having 1 minus m1 minus m2 kg of steam, and from 1 minus m1 minus m2 kg of steam, you are extracting m3 kg. So now what you are left with? So 1 minus m1 minus m2 minus m3 kg. So that much will be the resultant steam at the outlet of the turbine at point number 7. Okay, so at the point number 7 you can see that point number 7 is outlet of the turbine, that is low pressure turbine, and that will be supplied to the condenser. Okay, and you can see over here in the condenser you are supplying 1 minus m1 minus m2 minus m3 kg of steam. Because whatever stream we have extracted in the intermediate stages, that we have to neglect, okay, from 1 kg. Clear? So in condenser what will happen? In condenser steam will be converted into water. So at the condenser outlet, that is point number 8, the water that is available will be having mass of 1 minus m1 minus m2 minus m3 kg. Now this water is supplied to pump number 1, WP1. Okay, so what will happen? This pump will increase the pressure of the water, and this high pressure water will be supplied at heater 3, inlet of the heater 3. Now this is very important to understand. Now at the inlet of the heater 3 is for water inlet of the heater 3 is denoted by point number 9 on the diagram. Clear? Now you have heater, so from one point, that is point number 9, you are supplying water, that is 1 minus m1 minus m2 minus m3 kg, and from the top of the heater you are supplying m3 kg of steam. So what will happen? Obviously from one side you are supplying the water, and so from other side you are supplying the steam. So this steam will be converted into water, right? So now at point number 10, that is at the outlet of the heater 3, what you will have? So at the point number 10, that is at the outlet of the heater 3, you will have 1 minus m1 minus m2 kg of water or steam? Water, okay, not steam. Why, sir? Because when you are supplying m3 kg of steam from the top side, and you are supplying 1 minus m1 minus m2 minus m3 kg of water from the right hand side, then what will happen? Both will get mixed up, and this is called as open contact type heat exchanger or open contact type heater, okay, or feed water heater. Okay, so in this what will happen? Both the fluids which are supposed to transfer the heat are coming into contact. That is called as open contact type heater. Okay, remember that. So in this open contact type heater, what will happen? You mix the steam with the water, so the resultant will be the steam will be condensed into the water, and the water amount will be how much? So at point number 10, the mass of water will be, see, 1 minus m1 minus m2 minus m3 is entering from the right hand side, and you are adding m3. So this m3 is positive, here minus m3. So this m3 will be neglected. Ultimately, we are left with 1 minus m1 minus m2 kg of water at point number 10. That is supplied to pump number 2. So from pump number 2, at the outlet of the pump number 2, you will increase the pressure of the water, and that will be supplied back to the heater 2, right? So heater 2 inlet, that is denoted by point number 11 on the screen, as you can see over here, right? Remember students, from point number 11, you will have the mass of 1 minus m1 minus m2 kg. Clear? Now what will happen? For here for heater 2, from one side, that is from the right hand side, you are supplying 1 minus m1 minus m2 kg of water, and from the top side of the heater 2, you are supplying m2 kg of steam. So both will get mixed, and this steam will be converted into high temperature water. So now, so at the outlet of the heater, you will have heater 2, you will have at point number 12, you will have water of mass 1 minus m2 kg. Clear? Now further, this 1 minus m2 kg of mass is sent to the pump number 3. So this pump will increase the pressure, right, and it will be sent back to heater number 1. So heater number 1 inlet for water is highlighted by point number 13. Okay students, so now at point number 13, you are having mass of 1 minus m2 kg of water. Now see over here, for heater 1, what will happen? From one side, that is on the right hand side, you are entering 1 minus m2 kg of water at high temperature, and from the top side of the heater 1, you are entering and 1 kg of steam. So both will get mixed up and it will be converted into high temperature water. Now you tell me, or you think logically, at the outlet of the heater one, that is at point number 14, how much amount of what will be present? Obviously 1 kg of water will be present. Simple and easy to understand, right? So now this 1 kg of water, which is already at very high temperature, is supplied to pump number 4, and then it will be increase the pressure to the boiler pressure. So at point number 15 we have the boiler pressure, so it will be sent to the boiler. So in boiler, you know, the water will be converted into steam. Okay, so this whole process is repeating, and here you can appreciate that we have used the combination of reheat and regenerative. Now remember students, here for the sake of understanding I have presented 3 heaters, but sometimes in some author or some books 2 heaters are also used, so that is also right. Okay, so instead of using 3 heaters you can also use 2 heaters. Okay, clear? Now we will understand the TS diagram. So for understanding the TS diagram, we will simultaneously check the block diagram and TS diagram on the screen. So as you can see, we will start from point number 1, that is the inlet of high pressure turbine, and you have superheated steam at the inlet of high pressure turbine. So this high pressure steam will be extracted into high pressure turbine. So what will happen? See, at the intermediate stage at point number 2 in the turbine, you will extract m1 kg of steam, and that steam is supplied to the heater number 1, that is easily drawn by a line that is at low pressure, because you can see that if you are extracting the steam at intermediate stage, then your pressure will be decreased compared to the inlet pressure of the steam for the turbine. Okay, so now you can see at corresponding to point number 2, the line which is drawn is at low pressure. Now further what will happen? The remaining steam, that is how much, sir? That is 1 minus m1 kg. That will be supplied from 2 to 3, or that will be expanded in the turbine, high pressure turbine, from 2 to 3. Clear? Now what will happen? At the outlet of the turbine, high pressure turbine, that is at point number 3, now we have 1 minus m1 kg of steam, and we will reheat that. So now you can see on the TS diagram, if you are reheating that steam, so this reheating is taking place at 3 to 4 process, right? And you can see on the block diagram also that in between 3 to 4 your steam is in boiler, right? So now again you are reheating the steam to the previous high temperature, that is point number 4. Remember students, temperature of 4 number and temperature of 1 number are same, but the pressures are different. Okay, so now what will happen? At the low pressure turbine, you have superheated steam at T4 temperature. Okay, so now it will be expanded in the low pressure turbine. So now what will happen? As you can see, from 4 to 5. So at intermediate stage of the low pressure turbine, from 5 number point, we will extract m2 kg of steam, that is at somewhat lower pressure than the reheat pressure, right? So now what we are left with? Now we are left with 1 minus m2 minus m3 kg of steam. That will be further expanded, and then at another intermediate point, that is point number 6, we will extract m3 kg of steam. So now what we are left with? We are left with 1 minus m2 minus m3 kg of steam, that will be expanded during point 6 to 7. Remember, during 6 to 7, 1 minus m1 minus m2 minus m3 kg of steam will be expanded. Okay, now point number 7 is the inlet of the condenser, that is wet steam, right? So now what will happen? The condenser function is to convert the steam into water. So from 7 to 8 you can appreciate that 1 minus m2 minus m1 minus m2 minus m3 kg of wet steam is converted into water. Now from 8 to 9, that is what, from 8 to 9 you will have the pump number 1, right? And from 9 to 10, what will happen? You will have the heater number 3. Okay, same way from 10 to 11, 11 to 12, 12 to 13, 13 to 14, 14 to 15, same procedure will repeat, right? What procedure will repeat, sir? Simple. First you will increase the pressure, right? Observe 8 to 9 process. First you will increase the pressure, and then that high pressure water will be sent to the heater. and in that heater it is direct contact type heater. So what will happen? The steam and water will get mixed up, so the temperature of the water at the outlet of the heater will be increased, right? That is highlighted by process number 9 to 10, right? Clear? Okay. Acha, one more thing you will appreciate over here, that from top side for heater 1, heater 2 and heater 3, that if you observe, then from top side of heater 1, let us take example of heater 3 right now. Okay, so from top side of heater 3, we are supplying M3 kg of steam. Okay, and I have already told you that it is a direct contact type heater. Okay, so in direct contact type heater, what will happen? Your steam is directly coming in contact with the water, so it will be converted into the water. Okay, now let us visualize this in TS diagram. So now observe the point number 6 in the TS diagram. So now you can see point number 6 is in superheated region. Okay, so now what will happen? From point number 6, M3 kg of steam is extracted. So now you can see that superheating is decreasing, and slowly it has reached to the saturation vapor point. And further what will happen? Further it will reach towards the saturation liquid point. Okay, I hope you are getting my point, that M3 kg of steam which is extracted at the intermediate stage of the lower pressure turbine. Okay, so that steam is de-superheating. Okay, that means you are decreasing the temperature of the steam, okay, from 6 to the saturation temperature, and then you are converting the steam into the water, right? So that portion, that 6 to 10 process and 9 to 10 process, those both processes will take or occur simultaneously like this. Okay, 6 to 10 and 9 to 10. Okay, like this. Clear? Because practically, if you think logically, what will happen? From top side you will have the spray of steam, and from right hand side you will have the spray of water. Both will get mixed up. So from TS diagram, that will be occurring like this. Clear? Okay. So that same process will take place for all the other heaters and pump combination. Clear? Now let us find out the efficiency. Okay. Now for finding out the efficiency, you know that one should have the idea of turbine work, pump work, heat supply and heat rejected. Okay, so first of all we will identify the turbine work. Okay, so for finding out the turbine work, what we can write is, first of all, we have two turbines. We will first deal with the high pressure turbine. So let us write down the equation for high pressure turbine. Okay, so as you can see, 1 kg of steam is expanded from point number 1 to 2. Observe the block diagram. Okay, so as you can see in the block diagram, from 1 to 2 you have 1 kg of steam that is being expanded. So now you can directly take H1 minus H2 enthalpy. Clear? So that is our first term written for turbine work, that is H1 minus H2 plus. So here what will happen? So here, as you can see, initially you were having 1 kg of steam in the high pressure turbine, and from that 1 kg you are extracting M1 kg at the intermediate stage, that is at point number 2. So now what we are left with over here in the turbine itself, you are left with 1 minus M1 kg of steam. So now that 1 minus M1 kg into what points you have 2 and 3. So H2 minus H3. Clear? So H2 minus H3. So that is our second term, 1 minus M1, H2 minus H3. Okay, plus, so that is all about the high pressure turbine. Clear? Now we will write down the equation for low pressure turbine. So now for low pressure turbine, what will happen? Now for low pressure turbine, that is at point number 4, at the inlet of the low pressure turbine. So that is from 4 to 5. Okay, so from 4 to 5 you have how much mass? So from 4 to 5 the mass is 1 minus M1 kg again. Right? So 1 minus M1 kg into H4 minus H5. Clear? Further, from 5 to 6, how much mass do you have? Now see, from 1 minus M1 kg mass in the turbine, you are extracting M2 kg. So now what we are left with? 1 minus M1 minus M2 kg. Okay, if it is not clearly understandable, then you can also refer the TS diagram. Because there you will get the clear-cut idea that how much mass is remaining in the turbine. Observe the straight vertical line in the TS diagram. You will have the clear picture about during which portion or during which process how much mass will be there. Okay. So now, as we are talking between point number Next is 5 to 6, right? So from between 5 to 6 point, we have 1 minus m1 minus m2 kg of steam. Okay, so that is 1 minus m1 minus m2 kg of steam into h5 minus h6 plus final is what? 6 to 7. So between 6 to 7, how much mass is present for the steam? So 1 minus m1 minus m2 minus m3 kg. Simple. So that is how you can write the turbine work. Now for pump work, very easy to understand. Observe the TS diagram. Okay. So on the left hand section, that is nearer to saturated liquid line, you have straight vertical small lines, right? Observe that from 8 to 9, from 10 to 11, from 12 to 13, and from 14 to 15, right? I hope everyone can see that on the TS diagram. So you have to add all these terms, all these lines. Okay, but remember, you have to multiply the enthalpy difference with the respective mass. Okay, so remember, let us start with the bottom one, that is from 8 to 9 line. So as you can observe that during 8 to 9 line, how much mass will be there? So 1 minus m1 minus m2 minus m3 kg of mass will be there. You can easily observe it from the TS diagram, right? So 1 minus m1 minus m2 minus m3 kg of mass into h9 minus h8. Clear? So that is written. Okay, in pump what will happen? The later enthalpy will be higher than the former one. So keep that thing in your mind. Don't write h8 minus h9. You have to write h9 minus h8. Okay. Further what will happen? Further next pump, that is from 10 to 11. So from 10 to 11, how much mass will be there? Okay, 1 minus m1 minus m2. So for 1 minus m1 minus m2, enthalpy difference will be how much? h11 minus h10. Clear? Further, for next pump, that is pump number 3. So for pump number 3, we have exit points as 12 and 13. So for 12 and 13, how much mass will be there? So mass will be 1 minus m1 kg. So for 1 minus m1 kg, what is the enthalpy difference? h13 minus h12. Okay, same way pump number 4. So for pump number 4, you will have a mass of 1 kg complete. So now what are the end points of the pump? 14 and 15. So you write down h15 minus h14. Clear? Very easy, right? So that is how you can write down the pump. Now for the heat supply, students, as you can see in the diagram clearly, that between point 15 and 1, that is in the boiler, because heat supply will take place in the boiler. So from 15 to 1, you are adding the heat. And again, between point 3 to 4, observe the block diagram. Okay, because in block diagram you can see the 3 point is outlet of the high pressure turbine and 4 point is inlet of the low pressure turbine. In intermediate between that two, you are adding the heat. Okay, so observe the block diagram. 15 to 1, that is in boiler, that is heat addition, and also 3 to 4, that is also reheating. So you are adding the heat, so that is also heat addition. Now observe the TS diagram. Okay, now observe the TS diagram. Now in TS diagram, observe line 15 to 1, that is heat addition, agree, at high pressure, and now reheating. So line number 3 to 4, again at lower pressure, agree, right? So you have to add these both lines, so that will be your total heat addition. You know that, right? Because we have practiced this thing in heat cycle. Same way this is repeated over here also. So now what you will write? Q1 or heat addition is equal to H1 minus H15 plus 1 minus M1 into H4 minus H3. Clear? Now heat rejection. So for heat rejection, what you will write? For heat rejection, you can write. Now observe the condenser section in the block diagram. So as you can see in the block diagram, during the condenser section, the mass that is passing through the condenser is how much? 1 minus M1 minus M2 minus M3 kg. And what are the end points? The end points are, as easily you can see, 7 and 8. So simple. 1 minus M1 minus M2 minus M3 kg into H7 minus H8. Clear? Now observe the TS diagram for the same. So what will happen? As you can see in the TS diagram, observe the bottommost line. So you can see that for the bottommost line, that much heat is rejected. Okay, because for the bottommost line, what will happen? 7 point and 8 point. Between these two, if you take the area, below the 7, 8 line, that will be the amount of heat rejected. Now some might have query, okay sir, what about the upper horizontal lines? So see students, the area below the upper horizontal line that is not rejected heat, it is heat transfer. So to what heat transfer? Because it is heat transfer from the steam to the water in the heater. Observe what is the function of heaters. Heater 1, 2 and 3. There the heat is transferred, right, from the steam to the water. Okay, so it is not heat rejected, it is intermediate heat transfer. Okay, clear? Now in order to find the mass flow rate, okay, for this case one can apply the energy balance for heater 1, 2 and 3. Okay, so now let us apply the energy balance for heater number 1 first. So now you can see for heater number 1, at the top section you have m1 kg of steam entered. Now corresponding to that m1 kg of steam, what will be the enthalpy? Now you can see that m1 kg is extracted from point number 2. So that will be m1 into h2. Clear? Now what is I have already told you, whenever you are applying the energy balance, so simple concept is what? You have heater, inlet is equal to outlet. Keep that concept in mind. So now here in this heater what will happen? You have 2 inlets and 1 outlet. Okay, 2 inlets and 1 outlet. So one inlet is what? m1 kg into h2. Other inlet is what? 1 minus m1 kg into its enthalpy. What enthalpy it is carrying? It is h13. Okay, and further outlet. So at outlet how much mass is there? 1 kg complete. So 1 kg into how much enthalpy will it carry corresponding to what is the point? H14. So H14. Clear? I hope everyone is clear. Simple funda is what? For energy balance, the simple funda is inlet is equal to outlet. Here you have 2 inlets. So as you can see in the equation, first equation, you have for 2 inlet you have 2 terms on the left hand side, and for 1 outlet you have 1 term on the right hand side. Clear? Same way, let us apply the equation for heater number 2 and 3. Right? So for heater number 2, as you can see, further M2, that is the steam supplied at the top of the heater, M2 into what enthalpy it is carrying? H5. So M2 into H5 plus 1 minus M1 minus M2, that amount of water is entering on the right hand side of the heater, and what enthalpy it is carrying? H11. That is equivalent to how much? So what is the exit of heater 2? So that is 1 minus m1 kg. And how much will be the enthalpy it will be carrying? H12. Okay. So likewise, same way you can apply the equation for third heater also. So using this equation, one can find out the mass flow rate, right, at M1, M2, M3. Okay. So that is all for reheat regenerative side. Thank you.